Hey guys, welcome. Example 0 here on trig substitution, a Calc 2 topic. And since this is example 0, we're going to figure out why and how trig substitution works. Now, trig substitution is just another integration technique, albeit a more advanced integration technique. So in Calc 2, prior to learning trig sub, you should have already learned basic substitution, also known as U substitution, and integration by parts. With that said, suppose I give you this integral to work on. Neither basic substitution nor integration by parts are good approaches to solving this integral. And so what do? You do trig substitution. As the name says, trig substitution is a substitution for x or whatever other variable in terms of trigonometric functions. So here we're going to say x is equal to something involving sine or tangent or secant. In fact, those are the three substitutions we often like making in trig sub. Alright, now the way you suspect that you need trig sub is if inside of your integral, so in the integrand, you have a square root quantity, and then you've tried U substitution and integration by parts, and neither of them work. Then you should be like, hey, this square root quantity is too difficult and I can't try the basic methods, so let me try trig sub. Yeah? Okay, cool. So in this instance, the substitution that's correct is to allow x to be 3 sine theta. Yeah? And of course then you also need to figure out what dx will have to be, which in this case would be 3 times cosine theta d theta. But we're not going to solve this integral in full in this video. We're going to solve this integral in full in example 1. And so then we don't need to figure out what dx is here. Let's just concentrate on this square root quantity here, because that's where trig substitution is handy, like dealing with square root quantities that can't be dealt with in other ways. Yeah? Okay, cool. So with this substitution, what happens to this square root quantity? Let's look at it. It will turn into this, right? And then using exponent rules in this part, we can write 3 sine theta all squared is 9 times sine squared theta. Doing that, we can write this. And so we've got a 9 here, another 9 there. How wonderful. What are we going to do? Factor out the 9, right? And once we do, look at what we'll have inside of the square root. We'll have 9 times the quantity 1 minus sine squared theta. And of course, we love and know 1 minus sine squared theta as cosine squared theta from trigonometry. And so we can further reduce our square root quantity and write this instead. And now clearly both 9 and cosine squared can come out of the square root, and so we can simply write 3 cosine theta and no longer involve a square root quantity. Yeah? Okay, cool. So this is why trig sub is very useful. Alright, now since this is a very basic example, I want to give you a more sophisticated example or a more advanced example, and so let's make room. Yeah? So here it is. Now, there is a suggested table of substitutions you should make. So a suggestion for what kind of substitutions you should make. So if it's your first time like dealing with trig sub problems, it's very useful to have this table handy. So have this table right next to you. And so if you have a quantity inside of your square root that looks like this, the appropriate substitution will have to look like this, and so on. You get it. So let's look at this, your first test. So if we're given this integral here, what substitution should you make? Well, consult the table, and clearly the table suggests that you should make x equal to a divided by b times tan theta, or tan alpha, or whatever other Greek letter you like. Okay, cool. So if we do that, which is let x be a over b times tan theta here, the square root quantity will look like this to start. Now here we have a over b tan theta all squared, and that's for x squared, because this here is x, right, according to our substitution. And so using exponent rules in this part, we can simplify a little bit more and write this. Alright. And now where to from here? Clearly that b squared and that b squared right there are going to cancel, right? Okay, so once we cancel those b squareds, we can write this. And so just like the 9 here and the 9 there, from the earlier examples, we have an a squared here and an a squared here. And this is a convenience. What are we going to do? We're going to factor out this a squared and be able to write inside of our square root a squared times the quantity 1 plus tangent squared theta. But then we think of our trig identities and recall that 1 plus tangent squared theta is equal to secant squared theta. So we can write the square root quantity simply as a squared times secant squared theta. And of course, this can come out of the square root as a times secant theta and no longer require a square root. So this is why trig substitution is awesome, and I hope this example has explained very well, the use and how it works. Yeah? Cool. All right. Example 1, 2, and 3 will be progressively harder and harder problems, and so look out for those. And of course, I have more challenging examples, 2 of them, and then a very hard example as the final example in trig sub. Yeah? So be on the lookout for all of those videos to come, but otherwise, take care. Keep watching.